been growing rapidly. Their databases are also continuously gaining more and more storage. The databases are getting more and more distributed. A lot of databases have been created. If we take major organizations like Amazon or Facebook or any other social media platform, or even if we take non-social media platform or banking platforms, we know that database sizes has been continuously growing. Now the challenge is, how do we store these databases so that it is easily fetchable, we are able to read the data faster, we are able to process the data faster, and for that we should be able to track the data also. And also we have to ensure that data is always, integrity is there maintained, consistency is there, it is always available. So we have to follow ACID compliance also. So separately we will discuss on ACID compliance, but in this part we are going to discuss on the database sharding, which is going to help us manage such huge databases and maintaining so many records, which can be humongous and is still continuously growing. So let's jump into and understand how exactly this works. So what is DB sharding? DB sharding is a method of splitting a large database into smaller, faster, and more manageable pieces. Obviously, if the database is growing into petabytes, terabytes, it will become difficult because running a query, searching a record in that database will become more and more expensive, more and more difficult. For that purpose, we will have to break down the databases, like you can say shard 1, shard 2. So every piece is called shard. Whatever manageable piece is there, that is called shard. Each shard is an independent database handling a subset of the data. So the better way, so that we break the data also, and despite breaking the data we know where our data is stored. So let's say we have millions of user records. So those user records can be broken into smaller pieces based on different kind of conditions, maybe based on alphabetical order, or maybe based on their geolocation, or based on the kind of user IDs which are being created, right? And it is used in high traffic application to improve performance and scalability. Otherwise users will not be able to fetch that data, applications will become slow, and that is what we want to avoid. If you look into this architecture, you see that there are multiple applications and multiple database shards are being created, so that we can break the data into multiple pieces, and we can ensure that our database is always highly reliant, highly focused, and it gives speedy results. Database sharding helps us in improving database performance, obviously increasing the scalability by distributing data across multiple servers. So database should not get full. Let's say 1 petabyte, there is a limitation on the application side or the software side or the hardware side. So we can break those limitations and we can go beyond those limitations, because with the shardings we get the ability to scale our database horizontally. We can create as many shards as we want. It enhances the availability also, because when we create multiple shards, so we have the proper backup also, and we know that data is distributed, so it can be always recovered. It reduces the latency, obviously, when we are storing a limited amount of data in a particular database and we have limited records to search from. It is going to help us and make sure that our queries are getting faster results. To shard the database, we can shard it based on the range or based on some kind of hashes, where a unique key can be defined to each particular record. We can use geo-based hashing, like maybe Facebook is using database for user or social media platform or social media posts based on their reasons. Let's say for US it will be having a separate database, for Europe, EU region it will be having separate database, then maybe Southeast Asia or India or maybe Middle East, they would be having their own databases. So this way they can make and break the data into smaller parts, which will make it efficient. Then directory based sharding can also be done, where we can define a directory, and from that directory we can see like A, B, C, D, something like that, alphabetical order, or maybe any other format can be chosen from. The real world examples are Facebook, Amazon, Netflix, Twitter, which are managing huge amount of data, and they have to shard the databases so that they can continuously make efficient interactions with the databases. So these are like for Twitter, distributed tweets, Netflix user sharding for user watch history to improve streaming performance, Amazon shards product catalog, to optimize retrieval times, right? So we can have different products. So let's say if there is a mobile device, so we can have a separate database for mobile device, separate databases for home, or for home products, or groceries, or fashion. So they can have their own databases that will make it efficient. An online store like Amazon has millions of users and database. I think we have already discussed these examples, but you can find similar of such examples all across the internet and all across the IT stack. You will be able to make understanding on that. And ultimately, what are the benefits? It splits large databases into smaller, manageable, because when your database grows into petabytes, it will become unmanageable also. So that is also one thing which you have to take care. It has to be scalable, performance and availability also has to be improved. And then it is always already used by multiple organizations. So you know that this is something which works efficiently. There's nothing that which is not reliable, or there are some test or security related concerns. So there's no such issues. It has been already been tested and utilized by multiple organizations. And for high traffic application, it's a must. We have to go with Sharding. There's no other way. That's it. Thank you. Bye. Hopefully you liked it. If you, then hit the like button and then subscribe it to get similar videos in future also.